For centuries, humanity looked toward the night sky and believed the stars were distant, silent, and forever beyond our reach. Every point of light seemed fixed against the darkness, each one belonging to a universe we could only imagine. But every so often, something extraordinary enters our solar system. Not a planet. Not an ordinary comet. Instead, a traveler from another star. An object that formed around a distant sun long before Earth became the world we know today. Recently, astronomers turned the James Webb Space Telescope toward one of the most remarkable visitors ever discovered, 3I, Atlas, only the third confirmed interstellar object known to pass through our solar system. Unlike previous visitors that were observed only briefly, Webb's powerful infrared instruments are giving scientists an unprecedented opportunity to study the composition of material that originated around another star. This is not simply another comet. It is a messenger from another planetary system. Earlier interstellar objects, including Oumuamua in 2017 and 2I, Borisov in 2019, surprised astronomers because they arrived from outside our solar system on hyperbolic trajectories, meaning they are not gravitationally bound to the Sun. They entered. They passed through. And they continued their journey back into interstellar space. Now, Webb is helping scientists investigate another visitor with far greater precision. Although the telescope cannot photograph tiny surface details directly, its infrared observations reveal valuable information about temperature, dust, gas, and the chemical compounds surrounding the object. Those measurements tell a fascinating story. As sunlight warms the visitor, frozen materials begin to sublimate, releasing gas and microscopic dust into space. This creates a faint coma surrounding the object, allowing astronomers to analyze its chemical fingerprints. Within that expanding cloud, scientists search for water ice, carbon dioxide, carbon monoxide, methane, and complex organic molecules. These ingredients are not signs of life. Instead, they are the raw materials from which planets, moons, and perhaps even life itself can eventually emerge. That is why every spectrum recorded by Webb matters. It represents the chemistry of another stellar system. The object itself has likely spent millions, perhaps billions, of years drifting through interstellar space before crossing paths with our solar system. Along the way it endured intense cosmic radiation, freezing temperatures only a few degrees above absolute zero, and countless encounters with energetic particles traveling through the Milky Way. Yet it survived. Now, for a brief moment, humanity has the opportunity to study a visitor that originated under an entirely different star. Every observation brings us closer to understanding how planetary systems form throughout the galaxy. And perhaps, how common the ingredients for life truly are. What makes an interstellar object so remarkable is not simply where it is today. It is where it came from. Unlike planets or ordinary comets that orbit our Sun, this visitor follows a hyperbolic path through the solar system. Gravity bends its course only briefly before it continues its endless journey into the galaxy. It will never return. That trajectory tells scientists one important fact. This object was born somewhere else. Perhaps around a young star where giant planets scattered countless icy bodies into interstellar space. Perhaps during violent collisions that reshaped an ancient planetary system. Or perhaps from a region unlike anything found in our own solar system. For now, no one knows its exact birthplace. That mystery makes every observation even more valuable. Using infrared spectroscopy, the James Webb Space Telescope studies how different molecules absorb and emit light. Rather than producing ordinary photographs, Webb creates chemical fingerprints that reveal the composition of dust, ice, and gas surrounding the object. These fingerprints allow scientists to compare interstellar material with comets that formed around our own Sun. Some compounds appear remarkably familiar. Others may show subtle differences that help researchers understand how different planetary systems evolve. Even the object's motion provides important clues. Astronomers monitor tiny changes caused by sunlight heating the surface and releasing jets of gas. These gentle outflows can slightly alter the object's path, revealing information about its internal structure and activity. Every new measurement improves our understanding of these rare cosmic visitors. Their existence also changes how we think about the galaxy itself. Planetary systems are not completely isolated. During their formation, countless rocks, icy bodies, and fragments are ejected into interstellar space. Over billions of years, these objects drift between the stars. Occasionally, one enters another planetary system. That means material from distant stars can travel across the Milky Way, linking stellar systems in ways scientists are only beginning to appreciate. Perhaps the ingredients needed to build planets, and even the chemistry that eventually supports life, are shared far more widely than we once believed. Although no evidence suggests these objects carry life, they may carry valuable clues about how common life's building blocks are throughout the universe. This possibility is changing the way astronomers think about planetary evolution. Instead of viewing every solar system as an isolated island, scientists increasingly see the galaxy as a place where material can occasionally be exchanged over immense spans of time. Tiny fragments of rock and ice may wander for millions, or even billions, of years before briefly visiting another star. Every interstellar object that enters our solar system offers a rare opportunity to study that larger cosmic journey. Future observatories will take this research even further. Powerful telescopes, including the Vera C. Rubin Observatory and future space missions, are expected to discover many more interstellar visitors in the coming decades. Instead of finding only one object every several years, astronomers may eventually detect dozens each year, allowing scientists to compare their compositions, origins, and physical properties. Every new discovery will help answer one of astronomy's oldest questions. Are planetary systems throughout the galaxy built in similar ways, or is our solar system truly unique? For researchers, each new visitor is like receiving a natural sample from another stellar neighborhood, without ever leaving our own. Unlike meteorites that formed within the solar system, interstellar objects preserve a record of environments that existed around completely different stars. They carry clues about temperatures, chemistry, and planetary formation processes that may have unfolded billions of years before our own solar system was fully formed. Eventually, this visitor will disappear into the darkness once again. It will continue traveling between the stars for millions of years, long after it leaves our solar system behind. But for one brief moment in cosmic history, humanity had the technology to observe it. A telescope orbiting far from Earth captured light reflected from an object born around another sun. That achievement reminds us how far exploration has come. Every interstellar visitor is more than a scientific curiosity. It is a fragment of another solar system, carrying a story written long before our own civilization existed. And as we continue looking deeper into space, one question grows even more compelling. If these travelers can cross the galaxy, how many more are already passing silently through the darkness, still waiting to be discovered? Perhaps the next visitor is already approaching from a direction we have not yet searched. Perhaps it carries clues that will transform our understanding of how stars, planets, and even the ingredients for life are distributed across the Milky Way. One thing is certain.